Problem statement. There are more than 175 million handwritten pages sitting in US archives right now, and fewer than 5% of them are machine readable. Standard OCR was built for clean, printed text. It falls apart completely on 19th century cursive letters connected to ligatures with no clear boundaries. Ink fades unevenly, and writers used abbreviations no modern OCR training set has ever seen. The result is like a letter like this one, a draft of the Emancipation Proclamation can sit online as a digitized image for over a decade without a single searchable word coming out of it. That's the problem Archive Whisperer solves. Why agents? A single vision model prompt can transcribe a clean page reasonably well, but it can't validate its own output. It can't recover cleanly when an API call gets rate limited mid-run, and it gives you no way to actually measure whether it is correct. So I split the work across 4 specialized agents: a fetcher that receives the manuscript, a transcriber that does the actual reading, a validator that checks the result against human verified transcripts from the Library of Congress, and a formatter that produces the final report. And just as important, I made a deliberate design choice about where to use the live agentic reasoning versus where a direct deterministic call is simply more reliable. Now let's dive deep into the architecture. All 4 agents are built on Google's Agent Development Kit, each with its own model and its own instructions loaded directly from a versioned skill file. So the documentation and the actual behavior can never drift apart. They talk to a custom MCP server I built, exposing 3 tools: to fetch a page, look up ground truth, and to save a report. Here is the key design choice decision. Transcribing ambiguous handwriting genuinely requires judgment. So that step always uses Gemini vision reasoning. But fetching a URL or looking up a record by ID doesn't require judgment. There is exactly one correct action. So for those steps, I call MCP server directly, reserving the agentic reasoning for one place it actually earns its cost. Now we are going to see a live demo on one of the Lincoln papers, Emancipation Proclamation. So I asked anti-gravity to start on this. So it's first going to fetch like the 4-stage process. So it's already fetched the image. So this is from the Library of Congress. So this is the actual image fetched and from the MCP server, and then it's going to do the other stages now, transcribing, and also we have the output now. So this is the transcribed MD file which matches with that image, and also there is a text file generated. In addition, there is a JSON generated as well. So that's about it. That's our transcript output from the anti-gravity agent. Now let's run it against a page from Gibson Civil War Diary where I actually have human verified ground truth to check against. I'm going to kick off the Gibson Diary page 11 in the anti-gravity. So as you can see, this is the ground truth obtained from the human verified for Gibson page 11. So now it's going through that pipeline, and let's see how it compares. So it created the output, and also this is the original image. So all the 3 things matches: the image and the output created along with the Gibson truth. And there it is, real measured accuracy against independent source, not a guess. Now let's go through the build running the reproducible verified script in anti-gravity. Everything here is Python built on ADK with Gemini's vision model doing the actual reading. The test suite runs fully marked for speed, no API calls, no cost, with a separate live canary test to catch upstream changes. Security is enforced at every layer, including domain allow listing, rate limiting, prompt injection filtering, and an automated scanner that blocks any hard-coded credential from ever reaching GitHub. The whole thing is containerized, with the build verified automatically on every push through GitHub actions. It's a wrap up. Archive Whisperer turns invisible history into searchable text, reliably, measurably, and safely. Full code, test, and documentations are public on GitHub. Thanks for watching.